Hi guys, this is Mrs. Allison. Today we're going to look at more word problems. Before we get into any of the word problems, let's review the 4 steps that we've talked about before. The very first step, what should we do first every time? The very first thing we should do is to define our variables. This allows us to determine what the equation should be based on the words that are in the problem. Now there's a place where we can look for defining our variables. Where is it that we can find, or the best place to look, to decide what variables we should choose? Right, we are going to look at the last phrase or question for clues. Okay, so look at that last phrase or question for clues. Second step, now we need to write our equations. The third step is to solve the equations. Now yesterday, or the last time we were in class together, when we did the first set of word problems, almost every one of them were set up perfectly for elimination. There were a couple that we could definitely use substitution on, but they didn't really lend themselves to substitution as well. So today we're going to look at one type of problem that will almost always be a substitution problem. So you can really use either substitution or elimination, work best for this. Graphing, not as much. So I'm just going to put best with substitution or elimination. And I might just even underline elimination because it tends to be more common. And the fourth step, and maybe arguably the second most important step here, what is it? It is to explain our answer in terms of the problem. Okay, what does that mean? What that means is that we want to go back and say, okay, I got X to be this, and that means this for the problem. So let's look at an example. What I want you to do is hit pause and try the warm-up. All right, let's go through the warm-up. First thing we should do, define our variables. I tend to use X and Y, and I'm going to go to that last phrase. It says how many children and how many adults attended. Okay, so I'm going to define my variables. I'm going to let X equal adults and Y equal children. Great. Now my next step is to write my equations. So now I need to go back and actually read the rest of the words. The admission fee at a small fair is $1.50 for children and $4 for adults. And maybe I even highlight what we know. Adults were the X variable, and we said children were the Y variable. So I see those pieces of information. It says on a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults? All right, so when we're writing our equation, oftentimes the type of problem we have is a quantity and a value. My first and easiest equation is going to be my quantity equation. Remember, the quantity equation simply says this is how many people, in this case, came in. Well, there were only adults and children that came to the fair, and there were a total of 2,200 of them. Now, we got to go back to the next equation. And I see there's an expression that says $1.50 for children and $4 for adults. So when we talk about the money part of this, which will be my next equation, the number or the amount you spend per adult would be 4 times X plus 150Y equals, and the total amount collected is $5,050. All right, this sets itself up very nicely for elimination. So I'm going to go ahead and take this top equation and multiply it. Maybe I multiply it by negative 1.5 or negative 1.50. So we get negative 1.50x minus 1.50y equals negative 3,300. And now I can combine those two equations. So if I subtract, that kind of looks like 150, there's a decimal point in there. 4 minus 1.5, we get 2.50x. The y's eliminate, that was the point. And when I subtract 5,050 minus 3,300, I get 1,750 or 1,750. Now I'm going to divide by 2.50. To get x equals 700. Okay, now I'm going to go back into my equation. X plus y equals 1,500. Oops, sorry, that doesn't say that at all. It says x plus y equals 2,200. We know x is 700, so 700 plus y equals 2,200. I'm going to subtract 700. We get y equals 1,500. Okay, so we have gone through, we've solved, although I didn't really note that. And now we need to go through and explain what this means in terms of the problem. But keep it simple. I'm just going to take what y equals 1,500, which is children, and x equals, which is 700 in adults. And I'm going to put it in a very simple phrase. There are 700 adults and 1,500 children. And there is my answer. Another very common type of word problem that we'll see deals with money. I mean, I know we just dealt with money up above, but deals with coins and values of money. So let's start this one. I'm going to go to the question, and the first thing I'm going to do is to define my variables. So it says, how many nickels and quarters does Jane have? So I'm going to let x be nickels and y be quarters. And now comes the writing of the equation. So let's go back. If Jane has 36 coins totaling $3, she only has nickels and quarters. How many nickels and quarters does Jane have? Okay, so if she has 36 coins total, but she only has nickels and quarters, then really I have another quantity equation, because I have the equation x plus y equals the total of 36 coins. So the number of nickels plus the number of quarters equals 36 coins. Now it says it totals $3. So the first thing you should ask yourself is, am I going to use this in terms of dollars, or am I going to use this in terms of cents? Because there's actually two different equations we could write, and both are correct. So let's say we use dollars. Let's say I let this equal $3, like it says. How much is a nickel worth? It's worth 5 cents. But how do I express that in terms of dollars? Like if you were to see it on a price tag, what would it look like? Well, it would look like 0.05x. Then she has a quarter. What would a quarter look like on a price tag? It would say 0.25y. So this is one equation. This equation happens to be in terms of dollars. Okay, there is another equation I could write. And the other equation I could write would turn everything into cents. So we know a nickel's worth 5 cents. A quarter's worth 25 cents. But then what I would need to do is change the dollars into cents. So the $3. How many cents is $3? Well, we'd put 300 because this would be in cents. And you get to pick which equation you want to use, which one you think is easiest. I will tell you I tend to use the dollar equation. That doesn't mean it's wrong to use the cents equation. So you should get the same answer either way. So I'm going to use the dollars equation. And now I get to do elimination. And this elimination looks a little bit messier. But I'm going to multiply this top equation by negative 0.05. So I would get negative point, I don't know why I put a line there, negative 0.05 x minus 0.05 y. And then 36 times negative 0.05 is negative 1.80. And now I can add the two equations together. The goal was to eliminate the x. We did that. Now I get 0.20y equals 1.20. I'm going to divide by 0.2, or 20 cents. And we get y to be 6. And now what I need to do is go back and solve for the x variable. And I'm going to use the equation x plus y equals 36. We know y is 6, so when I subtract 6, we get x equals 30. Now again, I'm going to go back and define and explain my answer in terms of the problem. So x is nickels, so it says I have 30 nickels, and then I have 6 quarters. 30 nickels plus 6 quarters gives me 36 coins, and if I total up the value of those, I'd get $3. Okay, this last example is one I really want to show you. The first thing we need to talk about, I'm going to read the question, but before we even define our variables, I want to define some vocab words. It says, how many Blu-rays will Entertainment Emporium need to sell, and what is the break-even point? Do you know what it means to break even? To break even in business is when the money that is coming in is equal to the money that is going out. So for example, if you design t-shirts, you have to pay for the t-shirts and the printing materials. But then when you sell the t-shirts, you sell them for more than what you paid for them, and hopefully have factored in some margins to allow you to pay back like the printing press or the ink for the printer. And when the money you have coming in for the t-shirts is equal to the amount of money you put out, that's called the break-even point. So break-even is a very common thing to look at in business, and it's a great example of a word problem that uses substitution, or substitution is the best method. Now, the beauty of break-even problems is that your y variable is almost always going to be money. So let's define our variables, because that's the first thing we should do. And again, I'm going to look at that last phrase. How many Blu-rays? So I'm going to let x be the number of Blu-rays. Oops, Blu-ray doesn't have E. So x is the number of Blu-rays. And then because it's a break-even problem, I know y is money. Okay. Now, when I write my equations for a break-even problem, I'm going to have the money that's coming out, and I'm going to have the money that's coming in. These are going to be two separate equations. So the first equation, money that's going out. The cost to produce Blu-ray discs for Entertainment Emporium is $50 plus $5 per Blu-ray. That sounds an awful lot like the y equals mx plus b equations that we wrote last unit. In fact, it sounds like it because it is. Do you see that key phrase in there? Do you see that word per? Oops, that was a pen. Do you see the word per? It's a slope problem. It's a y equals mx plus b. So we get y equals the money that's going out. We have to pay $5 per Blu-ray plus a $50 fee. That doesn't change. That's like my starting point. So the money that's going out is y equals 5x plus 50. Now the money that's coming in, if you're charging $15 per Blu-ray, that's how much money's coming in. Now what we're going to do, what we're tasked to do, is to figure out what the break-even point is. How many Blu-rays do we need to sell, and what is the value? So look at this. This is set up perfectly as an equal values problem. So the way we would solve this problem is we would make a substitution. We know that y equals 15x, and so I'm going to take what y equals and substitute it in place of y in that second equation, or the first equation rather. So we would get, so we would get 15x in place of the y equals 5x plus 50. And now I can solve. So I'm going to start by solving by subtracting 5x. 10x equals 50, and then I'm going to divide by 10. And we get x equals 5. And again, you get to pick which equation you want to go back into. I might choose the second one. So we get y equals 15x, and in place of the x, I'm going to put a 5. So 15 times 5, so y equals 75. So here's how we explain this answer in terms of this particular problem. 5x equals 5 is the number of Blu-rays. So we would sell 5 Blu-rays to break even, and the break even point, which is money, is $75, which is my break even point. And that's what it looks like to do a break even problem. These are the most common examples of where substitution is used best, and a good y equals mx plus b problem. So feel free to rewatch this. Otherwise, there is a worksheet that goes along with this section, so feel free to get started on that.